if you have any questions, we'll take the questions at the end. So please do line up your questions.
Do you think you can control the right button? Okay. So, I'm Chris Lopik. I work here at Netflix. This
Hi.
is
Yeah, hi, I'm Jaydeep and I work at Uber.
Yes, you're not coming on.
I don't want Jordan to miss me, you know. So we're going to be talking a bit about the CEP 37, which is the auto repairs, which Uber has done a lot of work with, and we'll get into it. So yeah, pretty much everyone who's used Cassandra, it is absolutely necessary to have repairs running in your system, because without repairs, you can have data loss, you can have inconsistencies, you can have bit rot. There's all these things that are, it's a mechanism that Cassandra has always required people to use, yet it hasn't been very well supported. This is something that each individual company ends up building their own solutions for, which some have been open source, some haven't. And it leads to a lot of confusion in the community, because people who need to run this need to know, do they need to spin their own? Should they use this old open source one that hasn't had a commit to it in the last 3 years? Should they? And really, though, like compaction, this isn't something that is optional. This is something that needs to happen. So the motivation here is to put this into the database, not as some external system, but actually have it there for us. Yeah. So, and that's where the proposal is to take all these different implementations that everyone has had and take the core functionality of it and provide it as a feature of the database. Some of those is to support the multiple repair types, the different types of incremental, full, Paxos previews, and have little operator work involved, because people who are running this may not have enough expertise to do all these things, because it is actually quite difficult to get these running right. So kind of jumping into the design, there is a thread pool for each type of repair that's going to be on a scheduler. The history is going to be replicated in a new table, in new tables in the system distributed key space. And it'll be fully automated with no dependencies on the external orchestration control flows. So there'll be 2 new tables: the automated repair history and the auto repair history and the auto repair priority. The auto repair priority is more for operators who want to adjust the priority and say, oh, I want this, node run next, things like that, where the history is going to be used for the scheduler to identify which nodes need to be done next, and also provide some history for that pact. And it being in the system distributed key space means that it's already configured appropriately for all the different clusters to be appropriately replicated across availability, sorry, not availability, or data centers. So one thing that you have with repairs is there's multiple types: the full repairs and incremental repairs primarily, while usually you would just run one type of repair, like incremental. You still would periodically want preview or full repairs to run to identify things like bit rot or disk corruption, things like that. So it's good to have both types, but you may want to run them at different cycles and such. So each that's one of the things supported here. Kind of as a breakout is, for each Cassandra node, there's going to be the repair configuration, which is the schema configuration, or the scheduler configuration in the YAML. And then there'll be the system tables, which the auto repair schedule will pull both from those to run each of them. When the scheduler runs, it'll run every 5 minutes, configurable. It will decide whether it's its turn to run a repair next. If it is, it will update the repair history table. Then it will, with retries, run through all the key spaces and tables that are assigned to run, retrying fails and announcing completions. The configuration is done via YAML. and also through table options. The YAML is more for enabling and disabling the different types of repairs and setting the overall like repair threads, number of retries, things like that. These are all things that you can tune and change dynamically. The first is like the table properties, as there'll be 2 new properties. This is still a CEP, so the name can change, of course. But here we have automated full repair and automated repair incremental, where you can enable it and disable it on a table level through the DDL. And then the YAML for controlling the schema or the actual scheduler is just in your normal Cassandra YAML. Observability has been some new things have been added, exposed through JMX and also virtual tables. And there's also the existing virtual tables for repairs in general that David has recently added, which is fantastic. And with that, you could pull the metrics and do your dashboards and everything. So from nodetool's perspective, you can get the configuration and it'll dump it out. Kind of gives you an English as opposed to the title of the configuration option. So it'll actually give you a description of number of ranges, that kind of thing, as opposed to just a random YAML thing. For incremental repair, this is one of the things that I was excited to see as part of this CEP, and that's that incremental repair in particular, compared to normal repair, is very difficult. Primarily with enabling and disabling, going from a unincrementally repaired table to enabling it. That onboarding process is very expensive and difficult and hard to get right. And very few, if any, I've seen setups have ever worked well. So part of this was to help make a smooth migration for these larger clusters. For the migration, a couple things have been added here. One is the nodetool set repaired set. This is a little different than, for people who are familiar with this, there is a sstable repaired set command. But the problem with that command is it's mutating a database file while the database is running. So you have to shut the database off and then manually run it on every single sstable that is there. That process alone requires a whole nother level of infrastructure, and it's difficult and virtually impossible to do unless you've built automation to do it. So this has a nice nodetool command to do it. And the important part about having that is even if you're not using that to set everything as repaired initially, which you can use as kind of a cheat to get everything repaired right away, is if you enabled incremental repair and found out that your cluster can't support the performance impact of using incremental repair, it ends up creating 2 buckets, the repair data and the unrepaired data. And if the incremental repair can't keep up, those 2 buckets can't compact, and you end up running out of disk space. So you need to be able to undo it. And having a hot property tool, like having the nodetool command to just do it dynamically, is absolutely critical to being able to try a migration to incremental repair. Not yet in the pull request, but amazing, hopeful to be fleshed out feature is the unrepaired-bytes-based token range splitter, which is a mouthful, but the different, when the repair scheduler decides to repair a table, it will do splits. And while it'll take that table and split it into smaller chunks. So that way the repair isn't done at all at once, which helps with things like the Merkle tree and with the, if it fails and it took 3 days to run, then that means you wasted 3 days. So you want to be able to shrink it down. Unfortunately, setting just always split it 16 times or always split it 4 times or something like that isn't appropriate and doesn't always work. This will actually look at the unrepaired bytes, and how you assign how much you want in a repair, and it'll try to appropriately do the splitting that way, which is something that not only is difficult, it's without being inside the database isn't really something that you can even do. So that's something that's an awesome new thing to look forward to. And then also, because incremental repair has that ability to cause you to run out of disk by having those two different buckets, having a way to prevent running out of disk and just failing out and quitting is kind of an important fail safe for that migration. So little ship it squirrel, very cool in his red boat. This is currently being used by Uber in production. They have a nice blog post about that you can read. In Netflix here, we have this deployed in test, not in production yet, but the code is in test. And the pull request is available for where it's at right now. The CEP is in preview. I think Josh McKinsey, I don't think he's here. And JD, we're working more on that if you have questions about the CEP and where that's at. Yeah, that's where we're at. Questions? Yeah, probably move to the next person.
Thank you. While Dinesh is setting up, we'll be happy to take any quick questions if you have for the presenters.
Chris, does the patch do anything to affect tombstone based on history?
So that's I know what you're referring to, but so cool. Yes. So question is there anything with using the repair history to know about tombstone purgeability? Instead of relying on that, there is the table option to only purge range. There's a table option that you can set that says only purge tombstones that have been repaired. So then when things are in the incrementally repaired bucket, you can purge it safely. So the idea is, instead of using anything like how long it's been or GC grace, we can actually set the GC grace low to, like in the previous thing says, like 30 minutes. And then once things get moved into the repaired bucket, it can then safely be purged. So.
Question to previous speakers, though, if it's okay.
Yeah.
About limit by SLO. How do you imagine it? Is this like replica side SLO then, or client
per page?
Yeah, please.
Oh, my view of what the page by SLO would be is, like, just as an example from the Cassandra code side, is like limit, like right now you'd say like limit 200, say limit 200 milliseconds. And
200 milliseconds from what?
So right now there is a recent change added where there is the time from when the request got started. And while we do have to worry about like clock drift and things like that between the nodes, if it's set to something, you know, like 2 seconds, and you want to just give up at 2 seconds or something like that, for example, then if you could return, if like while paging, you could decide, instead of just checking the limit, if you've been past that time from when the original request started,
Okay.
then you would be able to return and just say, like, here's the page state would still be updated even if the result set is empty. So
Okay.
then from the page state, you can then iterate on.
Perfect.
So,
Yeah. I'm
sorry, I took the thing from you.
Yeah. Yeah. Mostly, I wanted to sort of include the queuing time on the coordinator side.
That was I think the queuing time is included in that, right?
It is optional,
David?
right? So we can switch. Yeah.
Yeah, that was added. That's even backported into 4.1 and stuff
Yeah,
too.
it
So
is. Yeah, I'm just.
yeah,
I'm just
from
trying to
that.
understand if that
Yeah.
that aligns well. Yeah, that's amazing. It's really.
If we can include the client side request time, then that would be perfect, because clock queues also we
That's
can.
the next thing that we are thinking about is essentially including the client start time in and have setting a deadline based of that. That would be probably the best.
Yeah,
Yeah, it will. Yeah.
but it'll take care of the clock queues and every issue that we have.
Thank you so
Any
much.
other questions?
I have two questions. The first one, the presentation will be shared.
Yes,
Yeah.
we will share the presentation and the
And the
recording.
second one, if it's working, this feature on Uber production, it means that they have fork version and cherry pick that.
JD?
Second, can you please repeat the
So
question?
if that feature is in review mode and it's running on Uber production, it means that you are working on fork and cherry pick that stage.
Oh yeah, currently, so we have our own fork of Apache Cassandra, and as part of this CEP, what at least we have done is, again, Josh and I are kind of working on kind of finalizing the content of the CEP and the design doc. So we have ported that Uber entire feature into open source 4.1.6 branch. The reason to port it to 4.1.6 is not to land onto 4.1.6, because most of the people are at this, on 4.1.6, so it is easy to review. But then we'll be porting the same to trunk as well.